I think it's fair to say that mathematicians like numbers a bit more than most. There are even some mathematicians who study numbers specifically. We call them number theorists. But most people don't really feel that way, like I said. Most people get a bit nervous if they see more than one or two numbers in a page at a given time. Certainly, I imagine a lot of you all who are in this class feel that way. Not to say you can't deal with numbers, but just that it's probably not something that you've had a whole lot of success with. To put it in the words of Scottish engineer and political economist William Playfair, making an appeal to the eye when proportion and magnitude are concerned is the best and readiest method of conveying a distinct idea. And to that end, we use some of the things that he and others came up with. Things like circle, bar, and line graphs, where the first one we're going to look at is what's called a circle graph, or as you may have heard it before, pie chart, where pie charts take circles and break them down into sectors. These are great for describing percentages of things, where some percent of people want one thing, some want another, and some want a third. And what we're going to do here for our first example is take a look at how we can make a quick estimate using a circle graph. Because like I said, people don't want all the numbers. They like something quick and easy to be able to get a general sense of the thing. And that's what we're going to see how we can do. So for this example, we want to consider the following pie graph, which describes how Americans define old age, taken from a sample of 219,345,624 people aged 25 or older, where we're going to use this to determine a calculation that shows the number of Americans who define old age by a decline in mental function, then use rounding to get a reasonable estimate for this computation. So what we need to do here is recognize that we want to identify the amount out of that total that define old age by a decline in mental function, where the first thing we can do is just recognize that that is our 32% sector that happens to be right on top. So if we want to get the total number there, what we would do is take the total number, the 219,345,624, and multiply it directly by our percentage, 32%, to get a number where when we multiply multiply percentages, we write them as decimals for the sake of that being what they represent. But even for me, this is a very clunky thing to do. Certainly not fun. Certainly not easy. So what we can do instead is do a little bit of rounding and round each of these off a little bit more to make our lives just a bit easier. We're going to round this one, and oh boy, I don't usually write approximates at that angle, so I'm going to change it a little. Still having trouble, but you get the idea, I think. That this, rounded to the nearest 10 million, so rounded to that digit, would give us 200, bad comma, too early, 220 million, which is a much more manageable number and still fairly accurate. Meanwhile, for our percentage, we're going to do the same sort of thing and round this one off to, it's not great, the nearest tenth, the nearest 10%, or 0.3. And if we do that, what we're going to end up with, instead of multiplying these two numbers, will end up being 66 million. Much, much easier to get that value there, where a quick trick for being able to multiply by tenths is you just divide by 10, then multiply by the number of tenths. Because 0.1 is a tenth of a thing, that means you remove the decimal place, so knock off one decimal from there, gets 22 million, then multiply by 3, gets 66 million. Where, for reference, if we didn't round this, what we would end up getting somewhat precisely would end up being 70,190,599.7 people, which is obviously too specific for human beings, so we have to do some rounding in there. And if we rounded, well, 66 to the nearest 10 million, again, it's kind of silly to round and then round, we'd still end up at about 70 million. So it's not quite as good as our approximate was in the other example, because we didn't have those nice numbers to deal with, and we have much bigger numbers here. Generally, when you have more digits, you have more room for error with these approximates, but it's still decent. Next, we're going to look at how we can handle this sort of process instead for dealing with bar graphs.